All right, this is Unit 7, Lesson 6, Translating Trigonometric Functions. So our lesson essential question is, how can you find and use translations of graphs of trigonometric functions? At the end of this lesson, you'll be able to use transformations to analyze and sketch graphs of trigonometric functions. Example 1, understand phase shift as a horizontal translation. How can you identify a horizontal translation from the rule of a trigonometric function? How does changing the value of h affect the graph of y equals 2 sine times sine of x minus h? For each transformed graph, the amplitude is 2 and the period is 2 pi. Changing h translates the graph left or right. Use the sliders to change the value of h. It does not change the amplitude or period. So here's the blue, which is our normal. And then here is the translation. So you can notice as I change, you can notice that it's shifting. So if I have 0, so it's 0, they're right over top of each other. But if it's positive, it's moving towards the right if you're looking at it. And if it's negative, it's going to move towards the left. So a horizontal translation of a periodic function is called a phase shift. How does changing the value of h affect the graph of y equals sine 2 times x minus h? So for each transformed graph, the amplitude is 1. For each graph, the period is pi. Changing h again shifts the graph left or right. See, it shifts. Notice that again, it will go back to that original starting position. So if I shift it over 3.14 or pi, notice it matches up again because my period is pi. So at 0, which is where it would normally start, okay, or at pi, they're right over top of each other. All right, so we want to try it. Sketch the graph. Y equals 3 cosine x plus pi over 4. Okay, so notice that I have an amplitude of 3. So I can go ahead and change that. It was originally 1, now it's 3. Okay. I don't have anything in front of the x, so my period stays the same. And then I have plus pi over 4, which is telling me to move 2 units, or pi over 4, to the left. So right now it's negative pi over 2, so minus pi over 4 would give me here, pi over 4. All right, so for b, y equals cosine times 3x plus 3 pi over 4. And I want to drag the points transform the parent function of y equals cosine x. Notice there's no number out front, which is my amplitude. So my amplitude is going to stay 1. Okay, I'm going to deal with the 3 first. The 3 is going to tell me how much I'm going to compress it. So that's my period. So I'm going to take 2 pi divided by 3, which gives me 2 pi over 3. So that's where my period's going to go. So 2 pi over 3. So that's 2/3 pi. And then I want to shift it 3 pi over 4. I'm shifting it to the left. So 3 pi over 4. We'll shift it to 5 pi over 4. So there's pi. Should be about right here. Okay. Make a couple points. Okay. And we can see that ours looks very similar to what they have graphed. So negative 5 pi over 12, which was our vertical shift. Great. Example 2, graph a sine or cosine function. How can knowledge of transformations help you sketch the graph of y equals 2 sine x over 2 plus 3? So sine x, remember our period is 2 pi and our amplitude is 1. So sine of x over 2, my period is 4 pi. Remember, we take 2 pi and divide it by whatever we have. So 2 pi divided by 1/2, which is right in front of the x, would give me 4 pi. Okay, the 2 out in front, remember, changes my amplitude to 2. Okay, so I went from this blue, just made it bigger or stretched it out more, to the green, which kept it stretched out but just made the amplitude taller. And then this plus 3 tells me that I'm going to move that graph up 3 units. Okay, so the period's 4 pi, the amplitude's 2, and the phase shift is 0, where the vertical shift is 3. Okay, so remember that phase shift, that left-right shift, is in those parentheses, and the vertical shift up and down is going to be outside the parentheses. All right, so let's try it. Sketch the graph of the function y equals 2/3 cosine x minus pi over 2 plus 1. Okay. So the first thing I'm going to look at is what's right here in front of the x. There's nothing, so that means my period doesn't change. Okay, it's still 2 pi because it's 2 pi divided by whatever is right here in front of this x. Now the 2/3 tells me that my amplitude changes from 1 to 2/3. So let's see, 1, 2, 2/3 is going to be right about here, roughly. Let's go in a little bit. So if here's 1, here's right about 2/3. Okay. Then this negative pi over 2 tells me that I'm moving left or right. Okay. So minus pi over 2 tells me that I'm moving pi over 2 this way. I'm moving to the right, so I'm going to go to 0. Okay. And then the plus 1 tells me I go up 1. Okay. So we looked at the period first. The period doesn't change. Then we looked at amplitude, which is 2/3, so it kind of squished it a little bit. Then we looked at the vertical, or the phase shift. Sorry, the horizontal, which is your phase shift, left or right. Okay, and it's minus pi over 2, so that's going to tell me that it's going to the right pi over 2 places. So from wherever it started, which at this point was negative pi over 2, we moved it to 0. And then it told me to go up 1. Example 3, analyze a sine or cosine function. What are the key features of the graph of the function y equals 4 cosine 3x plus 1? So y equals 4 cosine 3x plus 1 tells me the amplitude is 4. Remember, that's the number that's out in front. To calculate the period, I divide 2 pi by the coefficient of x. So 2 pi over 3 is my period. And the plus 1 is a vertical shift. So the graph of y equals 4 cosine 3x has been shifted up 1 unit. There is no phase shift. The graph has not been shifted horizontally from that of y equals cosine x. In terms of the general form, y equals a cosine b of x minus c plus d, where c equals 0. Sketching the graph can help make sense of these parameters. The amplitude of y equals cosine x is 1. Notice that for this function, the maximum value is 4 plus 1, or 5. And the minimum value is negative 4 plus 1, or negative 3. What are the key features of the graph of the function y equals negative 3 sine x plus pi over 2 minus 1? So y equals negative 3 sine x plus pi over 2 minus 2 gives me an amplitude of 3. Remember, I take that absolute value of the number that's out in front. I have no period shift. My period doesn't change, so that 2 pi is still 2 pi. My vertical shift, I have a minus 2, so I shifted 2 down. And then this plus pi over 2 gives me my phase shift, or my horizontal shift, which is pi over 2 units to the left. And remember, this is always the opposite direction that you probably think it is. So if it's plus, I'm going to the left. If it's minus, I'm going to the right. You can sketch the graph to check. Notice that the combined effects of the reflection and the phase shift produce a graph that could be interpreted as a sine graph without a reflection and with a phase shift pi over 2 units right. All right, so let's try it. Identify the amplitude, period, phase shift, vertical shift, and the maximum and minimum values of each function. So for A, I have y equals 1/2 sine x minus pi over 3 minus 4. All right, so let's start with the amplitude. Remember, the amplitude is the number that's out in front. In this case, it's 1/2 or 1/2. The period, remember, is the coefficient of x divided by 2/pi. So I have 2 pi divided by 1, which is just 2 pi. Okay. The phase shift or horizontal shift is the number that's within the parentheses, and it's minus pi over 3. So it's going to be a phase shift of pi over 3 to the right. Remember, it goes the opposite way that you think it would. And my horizontal or vertical shift is going to be minus 4, which means 4 units down. The maximum, the minimum value is going to be negative 4.5. Basically, I took my vertical shift and I added it to my amplitude. And then my maximum value is negative 3.5. It's 1/2 minus 4.5 is negative 3.5. And negative 1/2 minus 4 gives me that negative 4.5. For B, I have y equals 2 cosine 2x plus pi over 4 plus 2. So again, my amplitude is the number that's right out in front. So my amplitude's 2. My period is going to be 2 pi divided by whatever the coefficient of x is. So in this case, 2, which just simplifies to pi. My phase shift or my horizontal shift is going to be pi over 4. And that's going to be to the left. My vertical shift is 2. My minimum is going to be 2 minus 2, which is 0. And my maximum is going to be 2 plus 2, which is 4. Sometimes you just have to double check with these, especially like with the negative values. You can sometimes flip the minimum and maximum. So you're just subtracting 1 and adding 1. And then whichever one's the smaller, that's your minimum value. Whichever one's the larger, that's your maximum. Example 4, write the equation of a translation. So an assembly line machine stamps a company's logo on each product coming down the line. The graph models the stamp's height from the machine's axle, y, at time x seconds since the machine turns on. What is an equation that models this motion? Interpret the graph's y-intercept in terms of the context. Okay, so here we have the graph. Here's my machine. The sine function has a general form y equals a sine b times x minus c plus b. So we can see that it's going to cross here at approximately 0, 0. That's where we get the sine function from. The amplitude here is 1, so a equals 1. We can see by the graph that our amplitude, remember, it's the highest or lowest point from our midline, which happens to be y equals 0, or the x-axis. The period is 2 pi, so b equals 1 also. Okay. There is no vertical shift. The midline is the y-axis, just like the midline of y equals sine x, so d equals 0. The graph contains the point 3, 0, where the corresponding point on y equals sine x would be 0, 0. There's a horizontal shift of 3, so c equals 3. So an equation for the graph is y equals sine times x minus 3. At x equals 0, when the equipment is turned on, the equipment is near the midline of its cycle, moving down. All right, so let's try it. Write an equation that models the function represented by the graph. So here we can see a cosine function. Notice that when it crosses the y-axis, it's actually above where a 0 would be. So this is going to be a cosine function. So this is how we model a cofunction, just like we would a sine function. Y equals a cosine bx minus c plus d. Of course, you can use this as a sine function. You'll do the exact same thing. You might just have a different equation. Okay. So looking at this function, my amplitude is between -1 and -3. So that means it's moved down. My midline is going to be -2. Okay, so my amplitude is still 1 at this point. So A equals 1. So I have y equals cosine bx minus c plus c. My period, if I start at 0, I get 1 cycle through 2 pi, so b is 1 as well. So I get y equals cosine x minus c plus b. Right? There's no vertical shift, nothing's moved, or there's no horizontal shift, nothing's moved left or right, so c equals 0 as well. So y equals cosine x, right, plus d. But my midline has moved down to -2, so -2. So I have a vertical shift, -2. So I have y equals cosine x minus 2. And you can put the x in parentheses or not in parentheses, it's up to you. Example 5, find a trigonometric model. The table shows the average high temperature by month for Washington, D.C. How can these temperatures be modeled with a trigonometric graph? How does the midline function value compare with the average of the 12 temperatures? So here's my temperatures from January through December, highs of 43, 47, 56, 88, 87, and back down to 47. So formulate, assign numbers to represent the months of the year and create a scatter plot to show the pattern of temperatures in the table, repeating over a span of 2 years. So January, they assigned 1, 2, 2, 3, and so on up to 12. And then at January again, they repeated and went back to 13, so 13, 46. Okay. The temperature can be modeled by a function in the form y equals a sine b times x minus c plus d. Compute. Average the maximum and minimum temperatures to find the midline, or the vertical. So my maximum temperature was 88. My minimum value was 43. Okay. So 88 plus 43 over 2 gives me 65.5. So the vertical shift is d equals 65.5, which is where my midline is. Then I find the amplitude. So my amplitude is my max minus my min. Okay, so in this case, my maximum value is 88, my minimum value is 43. Divided by 2 gives me 22.5. So my amplitude is 22.5. The period is 12 months, so b equals 2 pi over 12, which is pi over 6. And I can estimate the phase shift, determine the phase shift by looking for the point where the graph crosses the midline. In the parent function, there is a 0 exactly at the origin. C is approximately 4. So remember, my midline was 65.5, which here's 60, so 65 is probably right around here. So right about 4. That's where they got that number from. So here is 65.5. It crosses about 4. It also crosses around 10, 16, and 22, just to give you an idea. So that's where they're getting this 4 from. So that's where the phase shift comes in. So my formula is y equals 22.5 sine pi over 6 x minus 4 plus 65.5. So the average of the 12 temperatures is 66.7 degrees. It's close to the midline value of 65.5. All right, let's try it. Write a trigonometric function to model the average high temperatures for Philadelphia, Pennsylvania. How does the midline value compare with the average of the 12 temperatures? So I'm going to look through and I'm follow this exact same pattern that I just used for this. What I can do is I can actually graph the functions, which I'm going to do. Okay. So I'm going to assign a value of 1 through 12 for each of my months. So 40. 2 is 44. 3 now that I've graphed my points, and all I did was when I got to 12, I actually just repeated the points. So 13, 14 are the same as, so like point 13 is the same as my first point and so on. So I just graphed all 24 points. So you can see that I have this function, this cosine, really the sine function, okay? So the sine function that goes up and down. So what I would like to do is take my lowest temperature and my highest temperature, and I'm going to add them together, divide by 2. That's going to give me my midline. So that's my average. So my lowest temperature is 140, and my highest temperature is 787. So I'm going to do 87 plus 40 and then divide by 2. Okay. 87 plus 40 and then divide by 2. 127 divided by 2, which equals 63.5. Okay, and that is my D value. So remember, we're going with y equals A sine B x minus C plus D. So D equals 63.5. We can do the same thing with these numbers and subtract them. So 87, that will give me my amplitude. Right now we have 23.5 B x minus C plus 63.5. Okay. To find B, I take the number of months, which is 12, and I do 2 pi divided by 12. So 2 pi divided by 12. Is going to be B equals pi over 6. Okay. And then if I look at my midline, so actually I'm going to add that in. So that's going to be y equals 63.5. Okay. So that'll just give me the idea. There's my midline. Okay, so this point comes up, which is 464, and 1664 come up. So it's about 4 would be approximately where my phase shift is. So C is approximately 4. So my final is y equals 23.5 sine pi over 6 x minus 4 plus 63.5. Okay. I can find the average temperatures. So the average, remember we just add them all up. So 40 plus 44 plus 53 plus 64 plus 74 plus 83 plus 87 plus 85 plus 78 plus 67 plus 56 plus 45. So the average is 776 divided by 12, which is 64.6. Repeating. Okay, which is 64.7. So that is actually, this average is close to the midline of 60. Concept summary, transformations of trigonometric functions. So again, I have my graph and then in words. So if I were looking at my sine function, I have y equals A sine B times x minus C plus D. Okay, so my amplitude was 2. That's the number that's right up front. Okay, so we can look at this. So the red line is my normal sine function. Okay, my blue is going to be the one that's changed. So my amplitude was 2, stretches the graph by a factor of 2. My period was 2 pi over b. In this case, b is 1/2. So 2 pi divided by 1/2 equals 4 pi. Remember, that means that the cycle, so up, down, up, repeats, or down, up, down, repeats every 4 pi units. Okay, so in this case, 4 pi is greater than my normal, which it would be 2 pi. Okay, phase shift is C, which equals pi over 2. That just tells me how the graph shifted from left or right. So remember, a minus pi over 2 shifts it to the right. A plus pi over 2 would shift it to the left. Okay, so if this was minus, it stays the same. It's just going to shift to the right. If this were a plus, it would actually shift to the left. And then this 1 at the end tells me that it shifted up. The entire graph shifts up one unit. And that is the end of Unit 7, Lesson 6.